Mic
Right.
and I will start my presentation. Higher axle load locomotives. We will discuss on some the latest locomotive which has the higher axle load. Again, we will summarize as a step checklist, and we will also discuss a few minutes about the shock transmission unit (STU). So, just starting first is a factor affecting the load hauling capacity. So, in this, I would like to show you this picture. Rolling stock and bridges both are interacting with each other by means of the loads. So that there is a mainly three factors. One is the UDL, means vertical load, axial load. Second is the longitudinal force, which is the in horizontal direction, and third is the speed. These are the three factors which is being transferred by the rolling stock to the upper bridges. Here we can say this is I am showing by the green color UDL. It is a vertical load which is coming to the superstructure directly. Longitudinal force, I am showing it in the red color. Basically, from superstructure, it is transferred from superstructure to the substructure. So we can say a major component of the longitudinal force, in fact, being bearing by the substructure, whereas the vertical load like axial load or UDL are being taken by the superstructure. This is the main basic understanding we should know for the when we are going the designing or we are the transferring. We were understanding the transfer. Third is the speed. Yes, due to speed of the our rolling stock, definitely it works on the both the component of the bridges on the superstructure as well as substructure both. So how it is working, so we will be discussing in further slides. So first is the hauling capacity of the locomotive. What are the factors are affecting the load hauling capacity of a locomotives? First, we will discuss about the rolling stock. In rolling stock, main is the locomotive, which is the haul the all others vehicles. So the main factor are the four factor: locomotive design, number of locos, track condition, rail wheel contact, and environmental condition. Here you will see, you can see in this slide, the locomotive design. It is the most important is a axle load. Although there is a load distribution, weight transfer, locomotive body, type of suspension, characteristic transmission there. But for a designer purpose, we need the axle load is the must for that. That is the more important. Second, the how many loco we are passing from our bridges. So number of bridges, single, double, triple, or multiple. Third is the track condition where the railways will contacting. Here the two components are very important. One is the gradient and another is the track curvature. Other is gradient will be depend on the train load, length of the gradient, and attack speed of train. Similarly, rail profile, vertical irregularities, alignment of attack, slip attack, etc. Also we cover in this track condition. Environmental condition like our track is dry hai or wet hai, oily hai or sanding hai. That also affect on the our active efforts on the locomotive. So before starting about the active efforts, we will discuss about the adhesion. Basically, adhesion, it is a friction. It is a positive friction is a adhesion. It means because of the interaction between wheel and rail, there is a adhesion. That's why the wheel are moving and going forward. If there will be no adhesion, means wheel will be slip in that case. So basically, it is a friction between steel of the wheel and steel of the rails. So same the you can say in case of friction, mu is equal to our total weight or whatever the reaction, that will be the ratio. Normally in steel to steel, it is a 44%, 0.4%. So this is the, so whatever be the total load is coming for moving it, the 44% is the active effort which is required. This is the more understanding about the to know the what is the tractive effort which is giving by the locomotive. Here, the important graph I would like to show you between tractive efforts or track, or we can see the resistance between rail and wheels, which is producing so that our train is going forward, and the speed of locomotive. Here we will see that the tractive resistance will be highest at the initial speed, and then after, because it is required to break the initial adhesion. When the adhesion will break, then drastically the tractive force will require reduce. Similarly, if we are considering the tractive efforts required for after breaking the initial adhesion, what will be the effect on the gradient or level crossing, then level track, then we will draw this graph, and where it is meeting, this is called the balancing speed. For calculating of tractive efforts of a engine, there is a formula. Tractive efforts required for hauling a train. There are four components which are required for hauling its speed. First component is T1, T2, T3 and T4. T1 is a train resistance, T2 is a locomotive resistance, T3 is the grade resistance of the our track grading of the track structures. Second is the curvature resistance. These are the four components which taking the giving the resistance for a for movement of a train. In fact, this tractive force will be T is equal to T1 plus T2 plus T3, and this has the relation with the power also. Power is equal to tractive force into speed, or horsepower. This can be calculated T into speed divided by 270. In fact, the resistance of train resistance and loco resistance can be calculated with a formula of total resistance is alpha, beta, A, B, C are the ratios. A is a static friction, B is a mechanical considerations, and C is a air resistance. So there are three resistance, and the B is a component of velocity, the speed, and C is a air resistance as a will be multiplied with the square of the speed. So with that, this formula we get, and by this formula, the tractive rolling resistance we calculate T1. So for various train combination like boxen in empty, boxen in filled wagon, box wagon, it is calculated here. Similarly, for the loco resistance, the formula is it is shown. You can see. So by that, the resistance is calculated. I am showing a sample calculation of how the tractive force is being calculated. So we have taken a WAG7 engine of which weight is 123 weight. It is running on a grade of 1/200 and 2 degree grade for just for sake of sample calculation. So which I will validate with the RDSO guideline which has been issued. So speed of the 50 kmph. So T is equal to T, again the same formula, and whatever we have calculated, the total tractive force coming 43.3. So this value already has been passed for the WAG7 engine. By seeing this example, we can see the which in all four component tractive efforts, which component is more important for our and just this is the main our outcome, so that we can feel that which component is hindering to pass our bridges for the clearing the substructure, clearing our bridges. Here we can see the train component is 39%, curvature is 8%, loco component is only 1.7%, and T3 is a great component of or required a tractive effort of a train, locomotive. So this is the very important. If the gradient of approach or our whatever be the ruling gradient is the higher, then definitely we require higher tractive force or multiple engine. If our gradient is lesser, then we require. Similarly, T1 means our train combination. If more number of heavy weight or more number of coaches are there, then definitely tractive force are more required. So this analysis various component will be help us to understand what are the effect of higher locomotive on our bridges. We will discussing this part in next slide also. There are two RDA these values have been calculated.
This meeting is being recorded and summarized.
Of this concept, how much tractive force or how many engines are required for hauling of the total loads are based on this the graph, and the formula was the formula for that. This is for the electrical locomotives. In x-axis it is a gradient and y-axis it is a tractive force. You will see the gradient up to the 100, 1 by 200. It is as good as very lenient. It is as a horizontal. But from 100 to 200, drastically increasing. It is increasing very high side. So that's why we are keeping a ruling gradient near. If we go 200 to 100, means more higher tractive force are required. Higher tractive force, number of locomotive or higher axle, higher tractive force wala we will require the engine. Our bridge will also take the more longitudinal force. So bridge will also be critical in that condition that we have to be understood. Similarly, graph between tractive efforts and speed, we can see initially to break the static component, it is required more tractive force. Then as soon as the speed increase after 30-40, then drastically tractive force requirement has been reduced. This is the factors of the rolling stock, which is required by the hauling capacity. Second factor I am taking about the bridge capacity, because this is the class about the interaction between rolling stock and the bridges. So what are the factors of which is required to calculate the bridge capacity for carrying our hauling rolling stock? So there are the main component bridge. Second is track and third is the geotechnical and hydrological properties. So bridges means condition of bridges. This is the very much important. Every time many of the factors are depends on the condition of the visual condition of that type of loading that we will discuss in our slide. Type of structure, foundation, substructure, superstructure, type of bearing, material, bridge geometry, span, width, etc. Similarly, track geometry, it is a state on curve or gradient, ballasted, unballasted, LWR or SEJ. Similarly, we also require geotechnical or hydrological detail like HFL, freeboard, clearance, buoyancy, cover depth, etc. etc. Now, the next we will discuss about the comparison of various loading standards. So, this slides, are you able to see? This is the very important slide. Here I am showing the various BG loading standard I am showing like BGML, RBG, MBG, 25 ton, HM loading and DFC loading. This is already shown in our bridge rule and detail is whatever. But by other color like standard B, it is not shown in bridge rule because it is earlier than BGML. It has came 1903. In fact, as a history we will see that earlier loading in BG 1875 and BG 1886 was also there. But now in current bridge rule, we are showing in the from BGML onwards. So as on today's date, we predict that all broad gauge line bridges are at least BGML standard. So what is the BGML standard? It came in 1926, where the axle load is the 22.9 ton. Trailing load 7.67 and tractive efforts it is a 47.6. Earlier the BGML, there was no concept of the tractive efforts. Means whatever we bridge are designed just for the loading other combination, but not for the considering the tractive force. Tractive force is a longitudinal force which is coming from our during acceleration and retraction from the of the our locomotives and transferring to the substructure. So, first time in BGML it is introduced as a 47.6 and braking force it is a percentage of the our tractive force. So actual brake load and so here we will see after that you can see the RBG came in 1975. The axle load was kept same, but tractive efforts has been increased 25%, 50% become 75 ton. Again 1987, you can see the axle load has been increased to 25 ton and the tractive efforts has been increased to 100, just double of the BGML. Again the 25 ton in 2008 come when the DFCS came. Then that times the 25 ton loading be introduced, where we have increased the tractive force of 126 ton because of the higher axle or higher tractive force. A new loco we have introduced which has the higher capacity, hauling capacity we introduced. So they are designed for the both DFC as well as 25 ton. So you can see that whatever the loading shown is the tractive force on the DFC and 25 ton both are the same. In fact 1995 HM loading also came for the heavy mineral loading. It was the mineral sites that was the different but DFC loading has been universalized for the 32.5 ton loading. So here is the main important for the IR purpose. The important is the 25 ton loading of here the axle load is the 25 ton and tractive force is 126 ton. The measure for the clearing bridges, about most of the 60% bridges are still on the BGML standard. So here you can see it was the axle load is the 22.9 means 30 ton. If we say approximate 30 ton and here the tractive force is the 50 ton. This is become 50 to 126 means it has been increased to 50%. Whereas this is 23%, 23 ton, 23 ton to 25 ton means 8 to 10% only increase. It is important to say that axle load is a vertical load and tractive force is a horizontal load. Vertical load major component is being transferred to the superstructure, whereas horizontal component tractive force is being transferred to the substructure. So by increasing, if we increase the axle load, our superstructure will be critical. If we increase the tractive force, substructure will be critical. So here the important thing, it is the only 8%, 23, even MBG was also 23%. So due to increase in axle load is only 8%, it means in superstructure not much criticalness increased. So most of the you will see RDSO has been passed our BGML standard rank also for the 25 ton or CC plus 8 plus 2 loadings. Whereas you can see this is the tractive force has been increased drastically. It means the whatever the due to introduction of the 25 ton loading or new heavier load, our tractive efforts are the major role for the design of the substructure. It means substructure are taking 250% more loading, more tractive load, more horizontal load, it means they are more critical, more vulnerable. That I wanted to say in this slide. So mainly due to higher axle load, higher hauling, the tractive longitudinal force, which is for the substructure, is the more important to check. Okay. So any question?
Yes, sir.
Any question up till now?
Sir, what is this trailing load? It has
Trailing
been
load
shown
is
in
the
the column number
basically,
4.
as per the bridge rule, whatever the loading diagram is shown, it is the total axle load of a one wagon divided by buffer to buffer distance. Like boxen wagon, it is a 10.71, and our axle load is a 25 ton into 4, means 100 divided by 10.71. Then for 25 ton it will be 9.3. So trailing load, it means total axle load divided by in the total distance.
Okay.
Okay, buffer to buffer distance of maximum wagon. Okay.
Good morning, sir.
Yes.
Sir, now it is told that the axle load will affect superstructure
Yes.
more, and this tractive effort will affect substructure.
Yes.
Then what is the effect of braking force
Yes.
on the whole
Definitely.
structure, sir? Can you please?
Longitudinal force is a two component: tractive
Okay.
efforts and braking force. Definitely, tractive force is governing. Normally, I will show you in the further slide. The tractive force is governing up to 50, 60 meter. Beyond that, the braking force is governing. In further slide, we will discuss in detail of that. So
Yes, sir.
initially it is a tractive force, and because tractive force is giving by the locomotive only, whereas braking force is the producing by the complete train. All axle are braking. So braking force is governing after 50-60 meter. I will show you the some of the calculation, then it will be clear.
Yes, sir.
Okay.
Thank you. Yes.
Thank you. Thank you. So I will proceed further. This is the calculation I have made RBG for the bending moment. CDA means coefficient. Here you will see the CDA formula for the BGL. RBG was different, and MBG 25 ton is become different. I will show you detail in next slide. Based on this calculation, I have plotted in a graph to understand better way the all other loadings. You can see the same Excel formula I have transferred in Excel flow, like a span and UDL. This is our UDL value for bending moment with CDA. This is including CDA. I hope everybody will understand CDA is a coefficient of dynamic augment, which is a formula I will already shown in the slide, and for the slide we will explain you the meaning of that. Here you will in the graph manner I am showing there, you will see that this is the BGML standard and this is the 25 ton loading. Mainly they are now it is as per the bridge rule, all new bridges has to be constructed or making fit for the 25 ton loading. So for the UDL consideration, we will see the whatever the BGML, the comparison of BGML. Red color is BGML and green color is 25 ton. You see the red up to the 30 meter. You can see up to the 30 meter. Red color is higher and green color is lower. I will show you in zoom condition. You can see I have shown in zoom condition. Are you able to see that BGML is higher than 25 ton lower? So all will be surprising how it is. It was the BGML is 23 ton and this is the 25 ton, and then how it is up to the 30 meter span. This is the 30, this is the lower BGML. Then it is increasing. Why it happens? So I will explain you. Again I am showing the same comparison between all loadings. So again, the oldest to 30 meter is higher. So I will show you the calculation. The CA for BGML and RPG bar is the 20 divided by 14 plus. For CD for BG 25 ton and DSC is the 0.15 plus 8 divided by 6 plus L. So you will see the CDA for example 30 meter. Yeah, please. बोलिए विवेक जी. Okay, so CDA for GML RBG bar is only 0.45, whereas CGA for MBG is become 0.37. It means it means reduced 18%. So CDA after the MBG has, that's why CDA has been reduced, and therefore the total UDL CDA instrumentation. I will also show you the BS 123 is on that. Sorry, 106 is on this calculation of experiment of for the calculating CDA. That time this is because of our fist plated joint and UDL for the 30 meter.
This meeting is being recorded and summarized.
25 ton loading is less than the BGML loading. It means the superstructure, most of the superstructures are safe by just correcting some few only bracings, etc. Superstructure are safe, or BGML superstructure are safe in 25. Okay, clear? So now coming to the part of the tractive force, we have cleared about the axle load. So same I have made the span BGML or all tractive force I am compared. You will see the maximum. Yes. So you can see the for VGML 47.6 is coming at the 30 meter. RBG highest is coming at the 34 meter, whereas MBG highest is the 100 ton. Similarly, 25 ton, and here I am also calculated some of the with the dispersion and percentage increase that I will show you then the graphical method. In graphics, you can see the y direction I am written tractive force and x is a for span. You will see the BGML is the 47 or 50 ton, whereas the 25 ton it is very high. It is increasing since within 1-2 meter it is increasing very drastically. It means the tractive force is increased. You can see in the graphical shape also the 25 ton is higher in all aspects. It means our substructure is taking higher tractive efforts than the from the BGM while we are running the 25 ton loading. But one important clause is in bridge rule about the dispersion 2.8.3. We will discuss more about that. That the 16 ton or 25%, whatever more is dispersion is required for the existing bridges, which will be dispersed to the approaches. So if we reduce the 16 ton or 25%, the dotted line, blue line we will see. So it means our bridges are coming to the equivalent to this loading. So our bridges are being safe in this condition. I will also discuss how the substructure code allow the overstressing. So that way we are saving our substructure also. That we will be discussing in further slides. Okay. So these are about the, I hope clear about the axle load, what is the impact of the axle load and what is the impact of the various tractive efforts of the various loading on our bridges. So Any question on this or shall I proceed? Because this is a very important.
Hello. Sir,
Yes.
BGMI business, sir, up to span without checking we can clear the business, sir, about as per the graph, sir.
For the BGML means for the axle load, if we will check up to 30 meter it is being clearing. But for the substructure, definitely you can see the with the dispersion. Discuss more about the clearing in further slides. You can see the graphical. Here we see near about 10 to 12 meter with the dispersion it is coming. But beyond that it is increasing. So every substructure has to be checked separately. Most of the substructure are passing because we have many of the redundancy in our stresses or in strength of the substructure.
Okay, sir, thank you.
Okay.
Okay, sir.
So now the next our outline topic is the codal provision. What are the codal provision for the are required for clearing of a rolling stock to check the rolling stock. So here I am taking the most IRPWM para 1202 about the CRS sanction. Second, we will be taking little part of the policy circular 6 which has latest revised in 2023. Some of the provision of bridge rule we will discuss for the, because with that only we will be able to clear the bridges for this. BS 135, it came in June 2024. Earlier RDSO issued the similar in 2004, the guidelines for clearing of rolling stock on railway bridges. Now in 24 they have revised it. The content was moreover same, not much change, but it is presented in a very good manner and all of the circulars and literature and paper has been covered in that and very good guidelines has been given. Hope all designers are able to using these guidelines. Based on this guideline, I will be discussing how to clear we will calculate how to clear the bridges. Second is the substructure code para 5.16 about the certification of the existing masonry and concrete substructure for introduction of new type locomotives that we will discuss. Third is the guideline for checking suitability of the existing substructure for 25-ton loading, which was issued by RDSO as BS 123. Third, we will discuss about the TLS, the instruction and given in the bridge manual, and the provisional speed certificate, some of the issued by the RDSO, that we will be discussion on that. So that we will be covering on the part of that. So this is about the IRPWM para 1202 about the CRS safety shall be obtained for opening the mostly it is required for opening of additional line of the railways, specifically bridge, opening of the extension junction level, remodeling of yard, rebuilding of the major and important bridges, and any alteration of reconstruction of material. So and similarly CRS sanction is not required for the construction, rebuilding, modification and strengthening of FOBs and ROBs, and regarding strengthening of all existing bridges other than minor bridges and major bridges, and the construction or rebuilding of the minor bridges are not required. So coming to the part of the policy circular number 6, earlier it came 2018, 2018, then it has been a revised and it has been a change, a very great change, and in the policy circular number 6. So this is the revised. Basically here you will see the whatever is shown by the red, it is the revision from the policy circular which was issued in 2018, and some two correction slip also came in between. Yeah, the most important is the policy as per the policy circular that the introduction of the locomotives were delegated from the first time. It will be by with the help of CCRS and relay board. Further, it was delegated to the joint certificate with the zonal railway. So the use of rolling stock already sanctioned by the central government railway board. DGRDSO also included in that for or running of the any section of the railway. In case of locomotive rolling stock sanctioned by the central government railway board or DGRDSO of running section of railway board, the same may be used for the zonal railway. Yet they also introduced one word, the new and derived locomotive. New design means whatever the newly chassis and further the some improvement has been done. So that was called the derived locomotives. So there is it is a very details. Mainly I am covering the clearing the bridges. So I will not be, in fact, if we will cover the full circular 6, then at least 2 hours webinar is required only for the policy circular number 6. But this is the main topic is about the how to clear the bridges. So just for introduction of that, because based on that only we are the authority who is the clearing of that we are taking. Now the important is our bridge rule, provision of bridge rule. What is the provision of bridge rule? About to access strength of the existing bridge. This is the important, how to assess the strength of the existing bridge. That is the main part that we will calculate how we will assess the strength of. So this rule is assigning to the strength of existing railway bridges given in clause 3 of IRS bridge rule. Here it is important that induced load should be less than design load. Definitely design load means bridges designed for which load should be higher than the whatever load is induced by the rolling stocks. The load considered for the clearance should be taking live load, impact load, longitudinal force, eccentricity, wind and seismic load. So some of the relaxation has been given in this clause for assessing of the existing structure. This is not applicable for new structure. For new structure, the 100% where we are passing, we are assessing strength of existing bridges. We are relaxing some of the stresses. Here we will be discussing for clearing of our rolling stocks. Here para 3.3 it says that span within 10 meter, the CDA may be reduced to 0.75 divided by span. Means up to 10 meter means 0.075 we can reduce, because it has been seen up to 7-8 meter it is the whatever the CDA is coming by that formula 0.15 divided by 6 by 8 plus L. The value up to 7 meter the CDA is by similar formula, it's very high. So that has been taken for the calculating for the lesser span. We can reduce 0.75 divided by span that has been considered, subjected to maximum reduction of only 20% of the calculated value for the span of 7.5 or less. Second, they are considering CDA calculated above may be multiplied by the factor VR upon V, where VR is the permissible speed, means 125 kmph, which is given, and the permissible speed and maximum speed is 125, which can be reduced at 20 to 40% reduction. Bridge found fit for 125 meter hours, bridge may be cleared to speed up to 160 meter per hours. It means this all bridges are designed for 125 kmph, whereas this para allows to clear the same configuration for the 160 kmph also. Even recently, as a provisional speed certificate for the some important trains, the trial runs are being done even for the 180 kmph also by the considering this para. However, whatever the reduction we are giving for the existing bridges, the CDA cell in no case should be less than the 0.1%. 0.1. So in that CDA was subject to condition that bridge, these whatever the CDA we are reducing, whatever we are compensation we are giving, that should be, one condition is important, which shall be in sound condition. It shall be certified that the speed will not be exceeded. Whatever the speed is given, that will not exceed. And if a speed is restricted to get the CDA within the limit, transportation branch responsible to ensure the speed restriction is rigidly observed. This, based on this condition, the relaxation for the existing bridges are given by the in the bridge rules. In this also they have given that actual UDL which is coming by the configuration has to be calculated by a software which is called moving load software, which is issued by the RDSO. This is for the analysis of bridges in place of UDL. This software is also available at our INSIN website. If a bridge is found inadequate for the loading standard, the bridge is to be checked using actual train load similar by this using above software. Para 3.5 says that checking of the adequacy of existing bridges for permitting rolling stock involving higher loads. The bridge shall not be considered for carrying out live load, and when the big wind pressure of depth level exceed 100 kg per meter square, because we will have to stop the train if the wind load speed increasing for that. Next, the para of that for the tractive force. Here the para 3.4 says about the train hauled by diesel or electric motor makes the tractive force shall be as specified for the locomotive distributed equally among the tractive axle, driving axle. It is called the tractive force. Braking force is the braking force for which locomotive shall be specified for them distributed equally among the brake axle together with 10% of weight of the brake or the trailing axles. So this is the braking force is taken by the all axle including the wagon also. Here the it is for the vacuum brakes 10%, whereas for trailing axle air brake it is considered 13.4%. But the directorate of the rolling stock has been given that the maximum tractive force even for the air brake being for the in bridge will be applicable is the 10%. So in the calculation we are taking the braking force of the 10% of the cell load. Next clause I was discussed about the dispersion and distribution of the longitudinal force. The dispersion as per the, it is very important clause, as I have shown in the graph by the dotted blue line. It was it is says that if our track is the open, means all condition like welded hai, railway fixing hai, or adequate anchorages are available and ballast forces are sufficient without SEJ, then dispersion to longitudinal force through track may be allowed to the 25% or 16 ton, whichever is more. It means if our maximum tractive force is coming the 64 ton, then up to 64 ton it will be considered as a 60 ton. Beyond 64 ton, that will be taken as a 20. Suppose our tractive force is 80 ton, then we will take the 20 ton.
कर लेना अपन पर बाहर लगा देंगे, अपन को भी ढूंढने में आसानी जाएगी ना, अपन को फाइल रखी है, ये भोपाल वाली से निकाला हूँ.
Okay. So also it has been shown that dispersion and distribution of longitudinal force for elastomeric bearing is 25%. Further may be increased to the 35%.
सबको उनको बोलिए ना कि जांच चालू करवाएं.
Santosh ji, please mute your computer. संतोष जी आपकी आवाज सबको डिस्टर्ब कर रही है. Yeah, thank you. But important condition, length of the approach for the above purpose shall be taken as the 30 meter, whatever the condition is given. The dispersion calculator shall not exceed the capacity of the track. And for new bridges or rebuilding, this is very important. For new bridges or rebuilding, dispersion as told should not be considered. Means whatever if you are designing new bridge, you should not take this dispersion clause. This dispersion clause is only for checking of the existing structures. And I will tell sometimes if we will check for GC loading, sometimes GC loading we will take the dispersion, and again we are checking this for checking of our locomotive. Then again we have taken dispersion. It means there may be chances of the double dispersion. So double dispersion is not allowed. So dispersion should be, that's why for new bridges no dispersion should be taken. Only for the checking of the, this is about the only existing bridges को check करने के लिए हमारा rolling stock पे dispersion we are taking. When considering seismic force, only 50% of gross tractive efforts or braking force to be reduced by taking dispersion and distribution. So we will be discussing now BS 135. We will be taking 5-minute break for we will any question before taking break? Any question till now? Yes, please. Any question?
No, sir.
No. Okay. So we will take a break. We will meet again 11:15. Okay?
Okay.
Thank you.
Yeah.
Yeah. Can you hear me?
Yes, sir.
Yes, sir, we can
Yes, sir.
hear you.
Okay.
Yes, sir. We are hearing you.
Yeah. Yeah.
Yes, please continue.
Come back again. The small break. And up till now, any question? Any doubt? No.
Sir, I have one doubt. Like
Yeah.
CDA effect reduces as we go down towards the substructure, towards the founding level. So the CDA effect mostly govern up to a particular depth in design of substructure. Is it correct, sir?
Yeah, CDA is for the substructure up to the 3 meter, it is reducing, and beyond the 3 meter it goes the zero. But
Yes.
only CDA, but main
Yes.
component will be remains. Many of the, I am seeing the many of the in design doing the all component are reducing. Not like that. Only CDA will reduced. In
Yes.
substructure code it is tells about the only CDA, not about the others.
Yes, sir.
Okay. Yes.
Sir, actually for RCC structures, we have to take full CDA effect.
Yeah.
Full CDA. So
For
what am
masonry,
I
it is for masonry. Yeah.
So I'm having one trestle beam, trestle column, and then I have a pile cap and pile. So should I take full CDA for the pile, sir, actually?
For pile, I have to see again because CDA, I think pile also we are not taking the CDA.
No, because actually if any buried bridges though, sir, I am from Southern Railway, Jayashree, maybe.
Yeah. How are you, Jayashree?
I'm fine, sir. Fine.
Okay.
Sir, I think
Your class is very interesting. Just this doubt we are having, because some of the bridges now what is happening is it is having a RCC trestle beam column. So we are taking full CDA till the bed level, but when we have to analyze check the pile for its bending capacity along with axial load. Should take full CDA, I just want.
Okay. I have to check it for that. For the
Okay, check and tell me, sir.
for that we have to reduce it. We are reducing the
Whether I
CDA.
should reduce or should I take the full CDA?
Yeah.
Because everything is RCC in this actually.
Because in RCC it is transferring directly. So
Directly, they should not reduce anything.
yes, but for like formation or whatever it is transferring, that's why we are reducing from from 3 to 0 formula. Okay.
Yes.
Till now, for about the loading, whatever we have discussed, any question about that? Whatever we have discussed.
Okay, sir. This doubt only I'm having. You can please.
Okay. So we will start about the BS report 135. Okay. Is it visible to your screen? RDSO BS report?
Yes, sir.
Okay. So we will
Yes.
start. This is the report. Yes. Okay. Thank you. So I will start now. This is the guidelines for clearing of rolling stock on railway bridges, on which our today's webinar is based. So we will discuss about this. Just a minute. Yeah. So this BS guidelines is on the main point is the general procedure for clearing of rolling stock. So first is the policy circular 6 brings out the role of railway board, RDSO, CRS and zonal railway regarding the speed certification. It deals in detail with the procedure for determining of speed of new or derived design of the locomotive, movement of new derived locomotive, reducing the speed of existing locomotive or rolling stock and restoring the same, or increasing the speed of existing locomotive or by making improvements, introduction of a passenger train on a specific route, speed trials and condition of operation, new or derived locomotive stocks and dispensation of detailed oscillation trials in respect of the derived stocks. Here the railway board is the controlling authority for safety on Indian Railway and is the final authority for regulating and sanctioning of new rolling stock with concurrence of CCRS. Whereas the derived rolling stocks are sanctioned by the DG RDSO. The responsibility for determining and certifying the speed has, however, been delegated by the railway board. So, as per this guidelines issued by the RDSO, the important the standard clause जो है speed certificate issued by the RDSO, it is that the clearance refers to the standard RDSO spans only. Whatever the speed certificate issued by the RDSO is that for standard RDSO spans only, which is bridges with the standard design, girder, slab, piers, slab, culvert, piers and abutment issued by the RDSO for BGML, RBG, MBG, 25 ton or DFC loading, etc. Other than these standard span like superstructure, another non-standard and bearing of special span design conducted by the zonal railway based on the site requirement, arches, substructure of all the bridges, standard RDSO span of standard RDSO span and special spans are to be got examined by the CBE of the concerned zonal railway. It means as per the speed certification guidelines are given for the standards only. Other all like substructure and non-standard superstructures are to be checked by the zonal railway under the chief bridge engineer, by the chief bridge engineer. This is the flow chart of speed clearance. First, we will collect the data of rolling stock by means of the speed certificate or the diagram of the concerned rolling stock. Then we will formation a train with the required formation, whatever formation has to be run with the locomotive and the concerned wagons or coaches. Then we will do the miscellaneous considerations, study of vertical load aspect and longitudinal load, whatever we have discussed in earlier. Then again, then speed of the, based on these three all consideration, we will find out the speed potential, and based on the whatever the maximum speed, minimum speed potential has been came on that, then we will clear the rolling stock for the that speed potential. That is the flow diagram. Okay. So what are the data required for clearing of a study? Like speed potential of the stocks, speed at which the stock train is to be cleared, train formation, axle load, axle distance, and attractive force, braking force, and height of the CG of the rail level stocks. Most of the data we get from the speed certificate. Like I will show the for the clearing of the loco trailing load to be assumed, for clearing of wagon coach locos to be assumed. Okay, so if we clear the, if we want to clear the locos, then we have to assume the concern, mostly for goods, we assume the box and wagons. And similarly, for the clearing of the wagons, we assume the whatever the locos will be assembled with that for that combination there. So this detail we will get from the speed certificate. One of the perform I am showing that for WAG 12B, like rolling stock, WAG 12B, maximum axle load, maximum tractive efforts, maximum dynamic braking force, and maximum braking force, and maximum CG. That data we will get from the speed certificate. BS 135 also given the center to center of axle load, tracting effort, braking force, and total length from buffer to buffer. It is shown. So that is as available in the annexure of BS 135. Most of the our locos, wagon, and coaches running in Indian Railway are given in BS 135. So it is a very good detail arranged by the BS 135 at one place. So we will have to be not to search any other places. An important thing that all center to center of the all axle like a Coco or Bobo, and in between the bogies distance center to center of nearby axle, and the buffer to buffer distance total length. So this data also required for making combination of axle for calculating the moving load and the tractive efforts. So that data will require. Similarly, this is given about the wagon and this is the data about the coaches. LHB, ICF, and Vande Bharat coaches data has been given here. Now the main calculation part, main principle of the for the vertical load consideration means axle load consideration. Mainly we have discussed that UDL plus CDA. जो भी whatever the UDL or CDA of the train formation is coming, that should be less than the which design for which has been designed UDL and designed CDA. It is very understood. It is a general design principle, but with this principle we will derive many of the formulas. The most practicable commonly used way of the reducing the impact load, here we can clear if we reduce the impact load by reducing the speed. So speed is also related with the impact load. Higher speed will give the higher impact load. So design load for which was designed. Here the standard bridges means BGML, RBG, MBG or 25 ton standard bridge which the drawing has been issued by the RDSO. Non-standard bridges for the which are the bridges which were non-standard design by the zonal railway, and that can be derived in percentage of the BGML in comparison with the BGML standard. So we can calculate the percentage of that positive or negative side of the that loading can be to make equivalent to the to understand the whatever the non-standard bridge is what is the status of the non-standard bridge with reference to standard bridge. Even when the axle load is within the design standard, the higher UDL may be induced on the some span due to closer spacing of axle. Yes, if axle spacing if closer, then UDL will definitely be increased. So this is the formula of given for the percentage strength for the non-standard bridge to be for calculation. So this is the how much the percentage is increased. Basically, this is the total live load total design UDL with impact by making equal to the total of our of train load and dividing by that it will be we get the percentage. Now this is the very important how we will take the maximum allowable speed VM. Here the load for which was designed This is the design load, UDL for design load, and UDL for design load into impact load ID, and for design ID, expected train load for train UDL for into IT. The IT is a ratio of our VD by VM, the speed of the whatever the speed proposed speed, and the design speed means 125 kmph. So making both the equal, and with that we can calculate the required design. By equating that, we can calculate the maximum allowable speed we can calculate. So by this method, this formula, we calculate the how much speed will be calculated. We will solve this by one of the example. I will show you, that will be more clear for you. So percentage strength of maximum allowable speed to be worked out by separate for bending moment and shear force UDL. So for bending moment, UDL for bending moment separately, and UDL for bending moment, and the max of the whatever will come, that will be considered for the percentage strength of that. Further, whatever the speed VM is coming, that will be reduced by 10% or 10 kmph, whichever less. This is very important. This is required because whatever we will certify the speed, we will reduce the 10% or 10 kmph, because when the trial run is done, that is done mostly 10% higher than the sanction, whatever we have designed. So that's why we have that value will be, our trial run will be done on that level. That's why we are reducing the 10%. This example I am showing, this is the WDG6G load co for CC plus 8 plus 2 on RBG with the on RBG standard. So clear span is 45.7, effective on overall span. So by that, as per the bridge rule, we calculate the table for 46 and 48. By interpolating that value, we will calculate for UDL bending moment, and similarly we calculate for UDL for shear force. And our CDA we will calculate as per the formula for this is RBG. So this formula will be 20 by 14 plus L. So this value is coming CDA, and VD maximum speed design speed, we are taking the 125 in all the cases. This is for the our RBG loading. This is WDG. This is our locomotive combination, train combination, WDG plus CC plus 8 plus 2 wagon. So we will run it on our moving load software. By this software, we will calculate the values and interpolate it on that value. And for WDG6, we calculate the maximum UDL for bending moment, maximum UDL for shear force. So the same formula, maximum speed, we will providing those value. This is the LLD, this is the train LLT or IDs, and this is the LLDs that we will provide. So we will get for shear force a bending moment 87.6, for shear force it is coming 84.4. So with that 90% by reducing 10%, it will be 78.86, means we are allowing 79 kmph. So longitudinal force consideration, we have there. This is the about the axle load consideration. About the longitudinal force means tractive force as specified for the loco distribution equally among the drive axles. It means whatever the in speed certificate tractive force is written, that will be divided by number of axle. Suppose there is a 4 axle or coco, it means 6 axle. So if it is a 60 ton, it is written, so 60 divided by 6. It means our every axle will take the 10 ton ka tractive force will be given. The braking force as specified for them locomotive, whatever the braking force, highest braking force which is given then 10% of the brake trailing load for the vacuum brakes. Mostly we are taking this the 10% of the trailing load because as per the wagon directives, braking force of bus and wagon has been restricted to the only 10% load. So the bridges are designed to construct prior to 1960 design without longitudinal force, does not depend on speed. A longitudinal force more than the design force would cause overstressing of the bridge component. Here we will discuss that standard bridge is designed for maximum tractive force or braking force due to standard loading. Longitudinal force governed of the bearing and substructure. So mainly the longitudinal force are designed important is the bearing. Specifically in bearing, the our holding down bolt bearing, which is the base plate is holding that, or our top saddle plate has been connected with the girder. So that bolt is longitudinal transferring for that, it has to be checked, and in the substructure, whole substructure has to be checked, and in open way girders, the longitudinal force is important for the design of the bracings, and the load transferring system also it is required. They also affect the design of bottom chord and bottom lateral bracings. Correct. Braking force govern in case of the longer span, whereas the tractive force efforts given in case of the shorter span. As you have asked, one of the participants asked about the braking force, the same clause for you, because braking force it has been seen up to 50 meter normally in most of the cases. Tractive force is governing. After that, the tractive braking force become higher than the tractive force because it is 50 meter means 2 engine. If 2 engine, then so all tractive force. Beyond that, there will be no tractive force, but braking force will be for all the including locomotive and wagons both. Tractive force and braking force are on increase due to introduction of higher horsepower locomotive and air brake trailing load. Most of the bridges are to be BGML standard or standard existing prior to that. So for longitudinal force design, it is there are 3 rules has been given, that tractive force and braking force whatever be coming, which is the more it should be less than the design longitudinal force. Definitely this is applicable for all the design, but if tractive force with dispersion or braking force is more than the design, then it will be failed. But if the tractive force or brake dispersion is less than the design longitudinal force, then also can be cleared. That goes for the only existing bridges. This is not for the new construction. So tractive force should be ever whatever be coming design longitudinal force, it will be less than for the with strengthened approaches. Next clause is mostly it is checked for 3 things. One is the axle load, second is become tractive force or longitudinal force, and third is the CG. So CG is taking for normal rolling stock is 1.83 mm, and for DFC it is taking as a 3 meter above rail level. If it is within that limit, then no need to be calculate further. If your rolling stock CG is within that, then no problem. Most of the rolling stock design within that CG limit. If anyhow ODC or any higher loading is to be cleared, that time CG has been checked. That time we have to be reduce the velocity with this the speed, the highest speed for the 1830 BGML or the height of the CG of the rolling stock, whatever be coming, the ratio of those height will be, velocity will be reduced in the same ratio. Okay. So Now we will discuss in case of the, these are the only considerations for the clearing of the higher axle load. Now we will discuss about the high speed train. What to check the high speed train, how to allow the bridge rule our says to allow the high speed load. So clearing of speed up to the 160 kmph. In fact, our bridge rule maximum speed are designed found fit for the 125 kmph. The VD is the 125 kmph. So VG, this one clause of VG, our bridge rule says that whatever be bridge is cleared for 125 kmph can also be cleared for the speed up to 160 kmph passenger services with stock specifically cleared to run such speed. So for clearance as per the our guidelines BS 135 for higher speed clearance to conduct a trial passenger train at speed above 160 kmph up to the 180 kmph, the same CDA may be extended up to the 180 kmph and stock may be cleared. However, this should not be as a guidance for clearing of stock for trials only. This is not for clearance of regular operation above 160 kmph, full-fledged study of the proposed speed will have to be carried out. But in fact, all speed increasing, the important is the confirmatory oscillation car run, COCR is the very important part. Because before introduction of speed up to 160 kmph, the passenger service bridge have to be monitored for the resonance tendency. During COCR, the bridge has to be checked for the resonance by doing the COCR. That has to be covered with the suitable speed distribution to check the tendency of resonance. So it has been detail has been given in the introduction of train at speed of 160 kmph, that CT20 report, and also the resonance study as a annexer has been given in this BS 135 for the more detail. The computer simulation study were conducted for BG up to the speed of 20 kmph per hour. For regular operation or higher speed beyond 160 kmph, the dynamic analysis of the bridges, train bridge interaction study and validation through trial are essentially required. Resonance of bridge, IRS bridge rule doesn't cover any phenomena about the resonance. So this rolling stock can be cleared or regularly operation if no resonance is observed in during bridge. So with the bridge can be cleared only by the same configuration by the checking of the COCR. In case of resonance tendencies observed, the clearance can be given with a suitable speed restriction based on the report of the trial to avoid resonance tendency of the during services. So this is the detail about the COCR or route providing runs. So these are the given these runs to be made for the establishment of fitness of the route. This is done for detailed oscillation trial. Scrutiny from UDL consideration has to be done. Scrutiny from longitudinal force consideration has to be done. The resonance and tendencies is to be observed during the COCR. PRR, which has to be instruction regarding the watch to be kept during the trials on the bridges for resonance tendency and mentioned. Heavy haul train also it is now the twins in a heavy haul are running being. So for that it is also given in this that how heavy haul trains shall be have different longitudinal train dynamics. These are high coupling force due to high buffering force and slacks, and due to sacks, summits and lack of coordination between locos. Further, heavy haul trains CDA, fatigue life and lateral force are expected to be different from the normal trains. This is the chapter about the substructure code, very important for because we know the axle load normally are not increasing much, only 8%, whereas 23 to 25 ton, whereas our longitudinal force increasing from 50 ton to 126 ton. For that, substructure code has to be checked, the para 5.16 of substructure code will help us for checking of such loadings. So this para, this is the chapter is called Certification of Existing Masonry and Concrete Substructure for Introduction of New Type of Locomotive, Rolling Stock and New Train Composition for gauge conversion. So as per this para, we will discuss in detail. This is the number one. It is very important. Whatever be the relaxation we will discussing in further slides, that has to be काले को बोलो जो लैटिन करते रहे मेरे को डिस्टर्बेंस होगा. That has to be opening of railway shall be based on the physical condition of the pier and abutment. So the most important is the whatever we will discuss. Before that, the physical condition is more important. If we here we will discuss about the allowing the higher active efforts and higher stretching. So that time we have to be, it is need to be check the physical condition. When new type of locomotive rolling stock to be permitted to run, section the first time, substructure of the bridges should be kept under observation as considered necessary by the chief engineer. Certification of substructure when new type of locomotive rolling stock of the train composition cause increase of the axle load or tractive force and braking force of over bridges. The theoretical stress in abutment and pier of existing bridges should be checked and that should be certified, shall be done for the appropriate action as per the whatever the criteria we will discuss now. This is the criteria about the masonry bridges. Here in overall you will see masonry bridges, what we will check first for the abutment or pier, we will take all the loaded, whatever the vertical loaded or horizontal loaded, which is be coming. Based on that, at that section, the maximum critical section, we will calculate the stresses, positive stresses or negative stresses. So compression or tension. So if it is the compression, then okay. If it is coming in the tension, then equivalent compression has to be calculated for that. So whatever the maximum compression is coming, if as per clause number 6, it is within the permissible limit, then no problem. We can clear the bridges. Even the stresses of the permissible stresses, it is coming more than 100%. Suppose the permissible stress is required 10 and our permissible compression stress coming 20, then also it can be cleared with the factor. Basically, the material strength is calculated with the factor of safety 6. It means its factor of safety has been reduced to the 3 with the without occasional load, or with occasional load it will be 2.25. So basically this factor of safety of material has been reduced. Then we can allow, should be allowed subject to good condition. Again, the physical condition should be good of the masonry as contemplated for GC by clause number 51. Same GC also same the speak about the same condition. Up to 200%. If the overstressing is 200%, it means we have reduced further the factor of safety up to the 2. Then in this case, we can allow the that load structure combination subjected to good condition of masonry and close observation of bridge. One sentence has been added: close observation of bridges as considered necessary by the CB after introduction of new locomotive, rolling stock or train composition. But if the value has been increased beyond 200%, then it should not be allowed. Then should be strengthened or rebuilt. Mostly in such type, we are doing the jacketing work and we are making it within the permissible limit. Here I have told that the compression should be equivalent. It means if there will be a tension like that, if our it is coming like this, maximum compression and tension. So this compression has to be, this tension has to be compensated to the increased equivalent compression, so that this can be taken like this. Okay, so this is called the equivalent compression stress. How this will be calculated, that I will discuss in the next slide. Okay, so here you can see the maximum tensile strength exceed by more than 10% of the value of contemplated in IRS substructure code by clause number so and so. Tensile joint shall be neglected and equivalent compressive stress shall be worked out. However, no overstress in tension shall be permitted in case of the arches. This is the for various type of masonry like brick masonry or rubble masonry, in different type, lawn mortar, cement mortar of different grade, that compression strength has been given in our substructure code. In fact, this even mass concrete also being checked, that value also given in our IS code, IS 456, and so based on that, the maximum compression is 0.34 FCK, and maximum working stress tensile strength is 0.034 FCK is coming. Based on that, M10 value also we can be calculated. So this is the permissible stress combination. So in case of occasional load combination, this 2 and 3 or 4, that factor of safety is showing in this table like this. So that is for that type of. So this is the about the masonry, and now we will discussing about the mass concrete abutment or pier abutment. Here the up to 50% of overstress in bending compressive stress. Beyond that, specified and CBC can be allowed subjected to good condition. Again, good condition everywhere, mass concrete and close observation. Here we allowed only the 50% of the overstressing, not 100 or 200%. Here you can see even for M10, our compressive strength is 340 in comparison to masonry is 2 months. So in fact, most of the mass concrete we checked not it is being passed because the compressive strength is too high than masonry. If the overstress compression exceed 50%, the substructure shall be strengthened, rebuilt to appropriate standard of loading. If maximum tensile stress exceed by more than 100% of the values as given in concrete bridge code, tensile joint shall be neglected and equivalent compression joint shall be worked out. Same it is given as the earlier we have discussed. So some of the important thing we will be discussed here. Whenever it is not possible to carry out theoretical, this is the further relaxation is given in this para by the board for clearing the substructure. Based on the heterogeneity and massiveness, it has seen that most important is the condition, good condition. It is given the more important. So yeah, we will see they are not possible to carry out the theoretical check, or wherever the result of the theoretical checks are found to be inconsistent with the physical sound condition of the existing bridge. Even our loading standard being increased and condition is sound, there the running of locomotive and loco stock with the heavier tractive force, braking force may be permitted, subjected to physical condition being certified and bridge being kept under close observation as considered necessary by the chief engineer. In such case, the necessary tractive force or braking force shall not be more than 20% over bridge. Okay? Above the level of tractive force and braking force running over the bridges for the past 1 year. Means in we have to be check every year if the condition is the permitted. Even then we will not increase the 20% from the previous year if it is running. In case where the tractive force is found to be exceeded the limit of the 20% mentioned above, the maximum tractive force of the locomotive to be considered may be fixed. Fixed means further we can use by means of the TLS. We will discuss in next provision of that. By CB in consultation with the mechanical and operating department for each specific bridge's location, keeping the view, the load to be hauled, the gradient approaches of the operating characteristics of the locomotive, subjected to the physical condition of the bridges being certified, sound and the bridge being kept under close observation as considered necessary by the chief engineer can be allowed. So same things we can calculate for the SBC of the foundation. We have to be checked not only material property, we have to be checked for the SBC of the structure. So as in that cases we have to be go for check at the bottom of a founding level. Here again the tension is if it is found to develop in one side, the foundation pressure should be recalculate on the reduced area of contact. Same the redistributed and equivalent compression has to be calculated. The maximum pressure so allowed shall not be exceed the safe allowable bearing capacity of the soil. And these are the stipulations has been given for the substructure code. Moreover, the same has been given in case of the GC loading also. Bridge strength of the bridge substructure should be checked in accordance with the provision of 5.3.3. Here they have given the existing gravity type structure to narrow gauge may be permitted to be retained after GC provided the maximum stresses developed in the substructure do not exceed the permissible stress stipulated earlier above. So this is the very important. 100% in case of compression in masonry structure. So that is allowed. Earlier it was allowed the 200%. In case of GC, only 100% in tension of the masonry of the structure that is given for the GC. This is the stress eccentricity, whatever be coming for the redistribution of load in compression tension. This is for the single axial direction, whatever be load coming by transferring the tensile force into the compression force. This is the current theory we are using, and for the biaxial also we will use this for biaxial, this type chart we use for the equivalent for calculating the equivalent compression force. So these are used for the calculating including compression force by avoiding the tensile forces. So even then, if it is the existing structure over stress we found to calculate, then we have to be go for the by strengthening by jacking, and should be designed for construction as the make the composite structure monolithically. So this is all about the our substructure code permission allowable up to the 200%, but the main thing here the 200% we can allow, but the structure should be in sound condition. Next is the TLS, whatever we are coming. What is the TLS? This is the our bridge manual para 224 which has been given for allowing higher powered locomotive on old bridge. The tractive force may have to be limited by multiple loco. Such bridges shall be identified CB. So mostly earlier the WDM2 was the 30 ton, 30.48 ton. So based on that the tractive force most of the bridges in BGML time maximum was cleared on that tractive force. So 30 ton is the TLS if we are taking. Then our most of the where it is going beyond that, with the help of TLS we can reduce it. I will show you one of the calculation in the graphical manner, then that will be clear to you. Then list of such bridges has to be displayed where the tractive force is limited to 30 ton per loco In double and multiple heavy operation is to be notified the working timetable. Locomotive which are thus restricted shall has to be possible to fit a TELS switch which when operated shall limit the tractive efforts generated by the each locomotive in 30 ton maximum. In locomotive where TLS is not provided, then tractive efforts shall be limited to 30% by controlling current amperage or tractive motors. So here for the these where the TLS provided, their caution indicator has to be given, and most of the if locos are not able to haul the train which get stuck near the bridges, their tractive efforts limited the required tractive efforts is more than 30 meters. The driver should not apply more tractive efforts and should ask the assisting engine for clearing the train. Basically, it has seen this higher tractive effort is required only while the starting the loco. So normally it is important to see the when the train is running normal speed, then the tractive efforts even this this tractive efforts meter also we can see in the locomotive, it is very less. But if when it is starting, the initial tractive efforts will be very high. That time only TLS is required. So it should be avoid the stopping the train and the approaches where the TLS is higher as per that. Then the operation of tractive efforts on such bridges are to be above of the made part of the learning of the loco pilot and assisted loco pilot. These are the given guidelines of that. In my opinion, I will discuss with you that as I have shown that in tractive efforts, the most of the 50% component of the ruling gradient 200, it was taken by the gradient. So in many of the cases, I have checked and make a report to the RDSO also in 2021, and that time we have checked the 95% of bridges which are critical in higher tractive efforts are not critical because of the tractive efforts which are if the bridges our approach gradient is not much, it is a smoothing gradient, then the tractive efforts will not come so much because the 50% component is the gradient that I wanted to say. So most of the bridges are passed without tractive efforts also. This is the guidelines has been issued by the Bridge Directorate BS 123, where they have cleared the various bridges for 25 ton loadings, various substructure basically. Mainly they have based on the same criteria, whatever we will discuss 5.16, they have checked and up to they have make a profile section. Up to that will be cleared. Like that they have given all details, and based on that they have given this profile. If the structure is beyond this profile, then our structure is safe. This is the most clearing dimension. So that they have given so many charts of that different type of loading and maximum work. So I have also made a software based on that value of on Excel. So that is we can see there. So for substructure, and this is for the PR. So this is all about the all code and manual which are speaks about the clearing of the which is we required for the clearing of rolling stock. And now we will take some of the examples, solved example to elaborate calculation to understand better for you. Meanwhile, if any question with you, we can discuss for that. Otherwise, we can go for evaluation of the same all principle and all formulas. Any question? So shall we proceed?
No.
Yes, sir.
Okay. Thank you. So this This part will help you for better understanding how to clear a bridge. Here I am showing the many of the new rolling stock like WDG6. This is very popular. I think heaviest axle load of this. Okay, this bridge has the heaviest locomotive axle loads. Most of the 22.9 or 22. This is the 23 plus 3% because this is a drive locomotive. So 3% extra load that they have given. So 23.69. WDG 12B, it is a twin Bobo type, means 4 plus 4, 8 axle locomotive hai. So there is the axle 6, this is 8 axle. WAG 12B, WAG 12H also came with Bobo. WAG 11, it is a Coco and it has a 12 axle, means twin engine का twin का बनाया है, and this also give a highest axle load, but in fact axle dividing per axle it is not much, it is 8.8. So this is WAG6, WAG99, WAG7. So highest is I feel this is the 8.2 and this is the 10 ton WAG12H heaviest load. These locos are now speed certificate or we are checking for that. So we will discuss one of the solve example. Normally we got such type of axle diagram. By that we will calculate this is the buffer to buffer distance and this is the buffer to first axle, then second axle, third axle, then fourth axle, then fifth axle, then sixth axle, then the last buffer, and then every axle giving our axle load, and every axle whatever with the tractor effort we are giving dividing according to the axle. So that from that end, for that calculation I made one of the axle load 23.6.
This meeting is being recorded and summarized.
Braking force is 29.15. Whatever is given as per the speed certificate is we are giving. This is the double loco. It is a Coco loco means and the rolling stock behind the train loading is a CC plus 8 plus 2. It means 22.82. CC plus 8 plus 2 का हमारा axle load होता है 22.82. So braking force is the 10% of axle load. It means it is a 2.282. So whatever we coming from the axle of the coaches or wagons. Here I am showing the axle number. So on bridge first axle, second axle, third axle, fourth axle. So 6 axle are of the first loco. Again 7 to 12 axle are the second loco. Then further axle of the this is the axle sequence I am showing. This is about the train loco. So all it is a very long time. As in the screen I am so able to see only the in detail. Further 59 of wagon, it will be very long table. So you can but just enter the detail that will take automatically, and then axle load. Then we will take it is coming the distance. So that distance A, B, C, D that I have shown in diagram, that is to be carried A, B, C, D, E, F. So that distance of engine, and the similarly we will show the distance of engine. So this is the automatically it will calculate the total length of engine. This is the cumulative distance from the first buffer to all axle cumulative distance up to the end. Then that he calculate the automatically tractive force directly by accumulating the tractive force on coming. Then braking force it is by accumulating weight. Then tractive force with dispersion. We have reduced 16 ton or 25 ton whatever. So whatever the coming the maximum longitudinal force is we have calculated. Accordingly, samely for the different span we get the maximum whatever the longitudinal force is coming. So by this longitudinal force we can calculate directly on this Excel program. This is for the WAG11 twin COCO locos. Similarly, we can just by providing, we can calculate. This is our output. Basically, we require on every 1 meter or 2 meter maximum axial force. So that we will calculate, that we will get for the further checking of the our speed set. Earlier, we used to do this such type the same axle we are saying the WAG12B2 engine by manually be doing. We have now converted in the Excel program. One of the software is by the issued by the RDSO for the moving load diagram. It is available with RDSO and can be downloaded from recent site also. So from that we give the same configuration whatever I have shown. So with that that program will run and we will get the bending moment, UDL for bending moment, UDL for shear force with the various span. So we will get maximum bending moment alag and then UDL. So our requirement is the UDL for bending moment and UDL for shear force. Based on this data, I have plotted these UDL for bending moment with CDA for the different span in comparison to the locomotive for better understanding. Rather than seeing the table, if we will plot, then we can understood. So you can see, as I have told, the WDG is the heaviest loco. So you can see the WDG 6G is a red color and BGML is a black color. So in all the cases up to the 60 meter span, the BGML is higher. Beyond 60 meter span, the WDG6 is going beyond that. We can know the very few span are more than 60 meter, which are the special spans. That has to be checked separately. Otherwise, for most of the span are passing in case of UDL. So that way we can plot and check the most of the spans are passing. More detail we are seeing. And this yellow color is about the DFC line. We are not analyzing the DFC loading for these things because DFC loading already safe for such structures. Same way, comparison of longitudinal force we have calculated for BGML, RBG, MBG, DFC with dispersion 25 ton, where WDG 6G, WDG 6G with the dispersion, where WDG with TLS also calculated. So we have, you can see that the attractive force diagram, here the BGML is the black color. This is the BGML loading, our existing bridge on this black color, and the proposed tractive effort of the 25 ton loading is this blue color. After the dispersion, it is the dotted line. So you can see that it is coming down. Further, WDG 6G is a red color. So you can see the red color line. It is initially it is higher, then it is become lower for the 12 meter. Then again it is higher and then higher. But if we applied the dispersion, this is the red color dotted line. This is basically orange color dotted line. So you can see with dispersion, with all the bridges, after dispersion it is coming everywhere is down. Okay, so this is the dispersion, but only 18 meter is going up. Here we will ask to apply the TLS. So this is be limiting to the 30 ton. So with that graph we have limited to the 30 ton. So this graph has been reduced. It means our all bridges have been saved except the 18 meter. We apply the TLS. So you can see the speed certificate of 18 WDG6G. They are asked to apply for the, if the twin loco is there, then 18 meter पे हमें TLS लगाने के लिए बोला है उसके बाद. The same about the WAG12B. This is the basically twin loco, है ना? So twin loco basically is a bobo type twin loco. So for higher speed they have designed this type of loco. This is the maybe seen WAG 12B. So same we have calculated by UDL for pending moment and UDL for shear force. Same way comparison of tractive force we have calculated, and we have plotted, and we found that our WAG 12B bridges up to 30 meter are safer with the dispersion. So that way we have to check our all bridges for, and even then if it is going beyond that, then substructure we can check for because it is for tractive force, and that allow to at 200% extra margin available in the our stresses. So here important I would like to say that dispersion is giving in the locomotive. Okay, if already bridge has been designed with the dispersion, then it is a mathematical, whatever the bridge, that should be only one should be dispersed. Either that bridge is, if the bridge is designed with dispersed load, then we should not consider the dispersion in the locomotive. If the bridge is without dispersion, then we can take the dispersion of that. So this is all about the checking various detail. So at last, I would like to summarize this webinar in how to do it. Start and collect the GAD and hydrological data, take dead load of superstructure, calculate SIDL, calculate live load according to span, including CDA, then calculate the self weight according to Codal provision. Then calculate longitudinal force, then take density of all the material, calculate other load as per the provision and bridge rule and substructure code, consider shape cut water and calculate the forces, calculate the self weight according to the Codal provision, then calculate sectional properties, area, movement of the interface, all horizontal, vertical, eccentricity, then by that head calculate the resultant movement, whatever be coming in the shape of like this, like positive or negative. Then analysis the substructure, then calculate the compressive or tensile strength, then take the compressive strength and tensile strength for substructure material, then calculate the compressive strength should be less than the permissible compressive strength, stress, and calculate the tensile strength, then less than should be permissible tensile strength. If it is the tensile strength, it is then equivalent compressive strength to it. If the maximum tensile stress exceed the permissible strength, then cut make equivalent compressive strength and neglect the tensile zone. Then calculate the equivalent compressive joint should be less than the permissible compressive joint. Then if it is within the limit, then it is safe. Then no. Even if it is failed, then we have to be plan the strengthening, rebuilding, and then we can to make our substructure safe. Even then, if we are not able to strengthen our substructure, or we are not able to rebuild our bridges, then there is one of the last solution that we will discuss here. So this slide is about the same which showing the flow diagram that check the suitability condition of the bridge structure, substructure has to be checked, overstressing be allowed, then TLS allowed, then if rebuild we will see the ejecting etc. Otherwise we can go for STU. So we can think for the STU as a pilot basis. Some of the railway are planned also. I don't have the exact data what are the status of their STU were. So in 2-3 years earlier they have planned for that with the help of the STU. So I will discuss what is the STU. It is called shock transmission unit. It means the basic concept of this shock transmission unit, whatever the longitudinal force is coming from the locomotive to the superstructure and being transferred from superstructure to substructure that has been dampened by the a shock transmission unit. So that was being dampened. So this is a fluid viscous type, this type of arrangement we have given. This is the detail about the shock transmission unit. Mostly such type of the mechanism of this is the shock transmission unit. This is all about how to clear a locomotive for higher axle and higher speed. So this is all about from my side. We have opened for the discussion and your queries. Yes, please.
Hello, sir.
Yes.
Sir, myself, Gopal from Deputy C Bridge from Eastern Railway.
Okay.
Actually, what we are doing for checking for higher loading standard, we have to check for fatigue analysis also.
Okay.
When we are doing fatigue analysis considering higher loading,
Mhm.
so in case residual life is coming negative. So in this case, what to do? What to take decision finally?
So residual life is coming negative in case of superstructure.
Yeah, superstructure.
Then definitely there is a one-off solution. You go for the instrumentation.
Okay. Yes, sir. Actually, same we are suggesting on file.
Go for instrumentation and check the actual effect of that, because there are many method of in fact RDSO earlier the detail about the fatigue life they have given. You go for instrumentation and verify for it.
Yes, 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 sir.
I think that will be the actual, you can validate whatever the value is coming, it is actually about that or not.
Yes, instrumentation actually gives the actual stress generated.
And whatever the condition, physical condition.
Yes, yes, yes.
What is the physical condition of the bridges?
Physical condition is good, but all bridges, what we are considering, all bridges more than 80 years old or 100 years old.
Okay, okay. So
Or
basically
those
it is an empirical formula that maybe you can verify actual condition of the bridges by the instrumentation. If the physical condition is sound, there is no sign of fatigue. Fatigue is I think the bridge may be okay.
But physical condition is okay, but I think instrumentation we have to process for instrumentation that will give actual
yeah,
stress
that will
generated.
give the realistic value. Definitely.
Realistic.
Definitely. Definitely.
Thank you, sir.
Welcome. Any more?
Hello. Sir,
Haji.
sir, in our case, sir, most of the bridges, sir, structural drawings are not available. In that case, how to clear the for higher acceleration?
Structural drawing is not available.
So not available, sir.
Most of the cases, as I have discussed, the superstructure critical, and about the superstructure, RDSO already given many of the guidelines. Only the has to be correct. It is the important the substructure, because the substructure loading is increased very high. Efforts increase very too much. So in that case, I will suggest that you have to be most of the drawings you can if it is open foundation, if drawing are not able, you can be take the bore log or take trial pit and plot the diagram, or even GPR etc. are coming for making the profile of them. Many of the railway doing the profiling of the existing bridges for arriving the drawings where the drawings are not available, because substructure has to be checked by the actual profile only. Okay. Without actual profile, we can't check the substructures. So at least by considering mass concrete or by considering substructure without RCC, we can check for that. So for that, we can check the profile by taking the profiling by various means, like bore log or by GPR, etc. I hope I have satisfied your question.
Yes, sir. Yes.
Okay. Okay.
Clear.
Any कोई specific problem railways are facing which are regarding any clearing of the higher locomotive, because these locomotives are already running since 3-4 years, or none of the, I think none of the any more than that locomotive have seen come. I have seen the RDSO site and discuss some of the railway. These are the latest locomotives which I have discussed today.
Good morning, sir. Can we take the PPT copy, sir? Can
Sure.
you?
This is the our course number 25216 at IRSIN website. You can get the IRSIN teaching material. Here by this number you can download PPT.
Without logging, sir? Without login, we can access.
There is no logging system. I will be loading that PPT on that site, and you can download from there. Okay.
Thank you, sir.
Sir, actually, for when we are replacing some steel girder with some PSC, so many bridges, that width is very less actually. We usually give only some 2.4 or 2.6 for PSC steel girders. Now we want to replace with PSC. I mean, for steel girders, PSC will be minimum we need 4.8.
Yes.
So full jacketing is becoming a big problem. That is one main issue. What to do with such bridges? Many bridges are facing the problem.
I think that maybe you can introduce the cantilever bed block.
Cantilever bed block we can introduce, sir.
Yeah.
That's what we have done in one bridge. We have introduced the cantilever. We have removed that. Existing bed block. We have replaced it.
Yes.
And giving a cantilever bed block and everything. All the things on the cantilever portion only. Even the bearing. So we are having to note whether it will be. We have designed it for the cantilever road actually.
Rather jacketing of the cutwater area. If we jacket the both side cutwater area,
because then what it becomes a split point of view, it is not okay, sir. If you do the jacketing fully, in the flood aspect, it's not coming okay actually.
Pardon?
Flood aspects, it's not coming okay.
Okay.
Because when width is increasing, no, sir.
Yes. In Western Railway for the side pathway, I have mostly I have designed independent side pathway, and that problem arises where to rest. There we have designed cantilever steel stool arrangement, so that we are resting. It is very light structure.
Very light. It's only 500 kg per meter square. Side path.
But for that you can design cantilever type pier cap.
We did actually cantilever type bed block, and the bearing, everything is sitting on the cantilever portion only.
That is only possibility.
Because that is the only possibility.
Yes.
Because that is the possibility. And circular column, another one issue, sir. There is an RCC circular trestle column, sir.
Yes.
And that is not RCC trestle column. Pier is like a column actually. Trestle column like that pier. It's not a solid pier. It's tractor force, more tractor force is coming also for 25 ton loading. That pier column is not safe. Can we do jacketing for RCC, sir?
Means it is failing in compressive stress or deflection?
Bending because of that horizontal load.
In bending stress,
we are having more vertical load also, because now existing is a girder. So girder with dead weight is less. We are going in for PSC now, sir. PSC U girder. So vertical load is getting more, and bending also it is more because of the heavier tractor force, sir. So we can, because it is the existing reinforcement is closely spaced. So how to do jacketing for that? The proposal is there.
Normally, in my opinion, jacketing doesn't help much for the RCC structure.
Yes.
Because RCC structure already having a very good strength. and the tensile member is taking that load. So basically it is a for masonry or even mass concrete it is a very good. For RCC it should be if it is not being safe it will be better to increase some more column and make it as a monolithic. I think that will be much better solution rather than jacketing.
No, monolithic also no, sir. Existing, they have to do some doubling those. Otherwise, how it will act as monolithic?
Like you will make some more structure from both sides, and at the top level or at the tie beam, bottom level, you can make a tie beam or make monolithic pier cap like that.
Because in this our case, everything rod is from the twistle beam is going inside the column, so we are having.
I think jacketing of the column will not serve the purpose. Even if you check, you will find it will not giving much help.
Yes, sir. Yes, sir.
Even you check, then
Yes,
I think it will not give much help.
Okay, sir.
Okay.
Not already.
Any more?
Good afternoon, sir. 5.16.2.2 का जो बताया है इसमें ये
Sir, please speak loudly. I am not able to listen you.
सर 5.16 का जो आप बताया सब स्ट्रक्चर कोड का उसमें आप ओवर स्पेस 200% तक मतलब जो उसमें लिखा हुआ है
Correct.
ये फैक्टर ऑफ सेफ्टी
Become 2.
हाँ ये समझ में नहीं आया.
बेसिकली जो मटेरियल का कैलकुलेशन दिखाया ना उन्होंने 11.5 उसी के 5.1 इसके पहले मटेरियल की you will see that this so that most value is coming for that. It is a material. It is a 55 ton per meter square. Basically, this is with the factor of 6.
Okay.
So, use that factor of safety. Any more? That is useful for you? Any feedback? Is it clear your doubts? And you are able to check your substructure?
Yes, sir. It has given very good insights.
Basically, the main concept of the comparison of our various loadings, it was most important. In bridge rule, it is a tabular form. So we have tried to show you in a comparison manner. One more important thing I want to share to all designers, it is very important thing. I will again come to the first slide where I have shown you this is okay. Here nobody asked about this GC loading. Do you know what is this? Anyone? Please, this red color GC loading.
Gauge conversion. It's gauge conversion loading.
Yeah, this is a gauge conversion loading.
Gauge conversion loading, sir, when MG lines were converted to broad gauge.
Yes. Thank you very much. Basically, this loading is not shown in our bridge rules, and many of our new engineers don't know about this loading, and they are clearing their bridges. They are not riding this loading because this is I will tell you about this loading. This GC loading came in picture around 1992, when the uni-gauge policies was there, and we wanted to make the broad gauge of the most of the meter gauge structures. So here what we have did, we increased the the waterway barrel length and both side by jetting method. cut water we have jacketed, like the madam has told earlier that it is width is less, so we have increased the width and both of the side, and we have checked the structure for maximum axle load of 20.32. It means it was lesser than the BGML load by considering of 2 WDM22 plus box and wagon, and this is cleared for the WDM22 has the tractive efforts of 30.48. So 2 WDM22 tractive efforts means 60.9. So two locos also within that. So many of the GC loading structures are failing in tension, especially arch bridges, because arch bridges, if it was extended end side, so and sleeper is resting old structures, and they are showing the very vulnerable location. I visited some of the structures. I have shown when outside it is going very good. When go inside of the bridges, the condition of the bridge is very poor. So it is my suggestion to all the zonal railway. Please check how many in most of the railways there are 3-4 sections are GC loading. By mistake, in somewhere has been written BGML or someone written MBG, RBG, because it is not shown in the bridge rule, and nobody knows about what is the GC loading, and they are clearing for the and normal. It is dangerous. Should aware about the GC loading.
Only that mistakenly they are
safe for
writing
the GC.
BGML or RBG. People are not aware.
Okay, how you were able to understand?
Gather got gas to meter gauge to broad gauge only.
Yeah.
Sir is telling by mistake they will mention RBG or MBGML. That's why that bridge is failing.
So check whether if it is strengthened or not strengthened. It is only JC loading, then they will be in critical condition. Okay. So I hope all queries has been satisfied. So can we go for conclusion? Last part, closing part, not conclusion. It is we can close the webinar, or anyone wants to say something.
Sir, one doubt is one just clarification, sir. I want to ask, sir.
Yes.
In case of doubling project, sir.
G.
Is there any guideline or some ready reckoner for checking of effect of this new double track on the existing bridges of existing track?
The guidelines means checking bill व procedure bill the same. Existing bridges जो आपका 5.16 है या bridge rule का third para 3 जो है, so these all are the for checking of the existing bridges, and then impact of the current. Basically you wanted to know that हमारा जो current bridges जो line है उसका जो existing पे क्या impact आएगा.
हाँ सर, डबलिंग ट्रैक जो उसके 5.3 या 6 मीटर
तो you have to be model it, or you have to be make in both the loadings, and then you have to check the what are the both the force diagram and the barrel length side, and then have to check the cumulative effect of that. Okay. That is the only method. है ना?
Sir.
So guidelines is nothing. This is the only whatever the bridge rule and substructure says. With that help, we have to be check it. है ना?
Sir.
Okay. So thank you very much for all the participants, and
Sir.
Yes.
Yeah, sir, I'm a deputy C, so design construction Bangalore.
Yeah.
And I'm Yoganand, sir. Sir, actually, I want some guidance, sir. If suppose one bridge is already constructed and there is no design drawings are available.
Yes.
Then how to check adequacy of that bridge, sir? In that case.
For substructure, we require the drawing. If we don't have the drawings, we have to be either make the borehole up to the foundation level. We need to get the actual profile. because
Yes,
the most critical section is just the our foundation bed, either at the
yes, sir.
founding level or the above the where the our section is reduced. That is the
Yes, sir.
most critical level. So we have to be checked there the maximum stresses comes. For that we required. So if we don't have, we can do the many of the method are coming and many of the consultants are showing like they are doing the bore log near that, and by the GPR or other method they are giving the profile. So there are in market there are many are doing the profiling and making the drawings based on the actual structure. That has to do it. Otherwise it is not possible.
Yes, sir. Sir, one more thing also, sir. There we don't have any so, so design drawing, sir.
Correct.
And we don't know that what
Okay.
is that exact enforcement is also, sir. And they're saying that it is not scannable. Yeah, sir, technology is not available, or it is not able to scan that. Actually, we face so much of difficulty.
Amortization. Like if our new bridges we are designing, and
Sir.
normally our major component is the longitudinal force. Transverse force is the very less. It is like wind or seismic case only.
Sir.
So major component is the longitudinal force. A longitudinal force we are designing our structure width and etc. as a new structure.
Sir.
So that way we can plan our whether load will not transfer to there, or making a construction joint, or if we are making monolithic, then also we can, if we don't have, then we can make a little bit construction joint and then we can do it. Or by making at top level we can increase the means founding our for that we can make separate, and for the pier cap level we can expand it. Like that we can make our design considerably if we don't have the drawing of the existing structure. That way we can go ahead.
Yes, sir. Sir, one more thing, sir. We required your guidance.
Yes.
With regard to, sir, nowadays we are going for all EPC contracts.
Yes, yes, yes.
Sir, EPC contracts में what is happening, sir? All they're adopting non-standard so designs actually.
Okay.
So by considering this economy, all these things, sir. So, sir, if you're going for these designs as per site specific, there is a chances that in future we may miss the drawings, and the drawing should be preserved very carefully, sir. Or otherwise, in maintenance, it will be very difficult, sir. Matlab, something happens in the future, and so during course of this maintenance, and we will be requiring that design drawings. So that problem will face, sir, in future.
In fact, BMS will help us in that way.
Sir.
BMS में हम अपना ड्राइंग्स वगैरह सब रख के हम प्रिजर्व कर सकते हैं. That is so there are many, and then one of the also when we are handing taking over के लिए भी एक already ऐप बना हुआ है जिसके थ्रू और more with tax saving that we can be preserved rather than earlier. But major problem as you are saying that we are not having the existing bridge drawings or
Yes, sir.
Sorry,
Non-standard, sir.
standard.
Non-standard.
So I will suggest even railway board also told that as far as possible we have to be insist for the standard drawings only. Wherever it is not possible, then only we can go for.
क्वेश्चन में डाउनलोड कैसे कंटिन्यू చేస్తాను వాట్సాప్ లో
Please mute your mic, senior DN Voltaire sir. अपना माइक म्यूट कर दीजिए. Okay. So here I wanted to say that when our non-standard, as far as we have to be for EPC contract, we have to be go for standard drawings wherever available, and where it is not feasible, then only it has to be think for the standard drawing. Even
sir, yes, sir.
Yes, sir.
Sir, if it is yes, sir. If we are not able to adopt non-standard standard drawings, is it that any procedure is quoted anywhere, sir, in policy matters that we should take approval of?
Yes, it is quoted in RDSO checklist for the preparation of GAD by the railway. It is given there in that checklist. It should be or RDSO.
Yes, sir.
रेलवे का लेटर है, उसका भी उसमें दिया है. 35 पेज का वो चेकलिस्ट है, उसमें डिटेल दिया हुआ है इसके लिए. यू कैन कोट दैट लेटर.
यस सर, यस सर.
है ना, उसमें दिया है कि आपको स्टैंडर्ड ड्राइंग ही फॉलो करना है.
We are doing, sir. Even they are adopting also. That EPC में we are adopting non-standard drawings. But yes, my concern is that, sir, in future में if you go on adopting non-standard drawings, maintenance में issue होगा, sir. Now we are facing the problem with that existing bridge का we don't have that so design drawings, and for checking of adequacy, and we are not able to check. So it is very
yes,
so it is becoming very difficult to find adequacy.
I agree with you. Even
yes,
that's why I am saying as far as possible we should go. Even then, if any site constraint, any specific constraint, then you can go. But in that case, one important thing I wanted to tell, first of that drawing has to be preserved. Second, the interaction ratio between the permissible stress and the actual stress should not be very closer to 0.99. Many of the EPC designer are giving very close percentage. You may be knowing that RDSO is designing near about interaction ratio of 0.7.
Sir.
So, as far as possible, we should not go beyond 0.85. If we are going to, we are foreseen and further, or if any design criteria, if anything lost, then it will be very dangerous. So when I was the deputy design, I make a practice of the asking interaction ratio within the 0.85.
Yes, sir.
So that way we can make our structure more safer.
Yes, sir. Thank you so much, sir.
Welcome.
Sir, actually mainly for few bridges though, sir, RDSO is not given any drawings, sir. We are not able to get any standard. We have to really design. We are replacing existing steel girder with PSC. Then for skew means there is no standard design available in RDSO, sir. So
yes.
We have to either design by ourselves, and we cannot go for RCC more than 3.5 meters actually. Previously we used to do even for 12 meters also we used to design RCC slab in our railways, other meters. But now so they are CRS objecting, why are you doing for more than 3.5 meters? So essentially we have to go for outside design only. So it becomes non-standard only. All of them becomes non-standard.
I agree with you for the skew structure, sir. For existing skew, this is the problem. In fact, Western Railway, we have made a non-standard drawing of lesser width also by making a offset and clearing, and somewhere we are even by checking that. That is the problem with that. But RDSO also having the problem, they cannot make a design for a specific case.
At least for some range of skew they can give, it will be better, sir, actually. Like some range if they mention.
Yes, that is important. I agree with you.
That can tell RDSO because we are finding so much of problem for skew bridges.
If it is a 9.15 meter clear span, and then RDSO, if it will write it is 8.5 or it is up to 8, it is safe. then we can use it.
We can use it, yes, sir.
Yeah. So that will be more useful.
Because non-standard.
Yes, yes. In BSc, you can raise this issue.
Steel girder, we can design and skew.
You can raise this issue in BSc or civil defense.
Thanks, actually.
RDSO can help for that.
Yes, sir.
Just by checking the drawing. In fact, Western Railway, I checked many of the drawing and we have reduced half to 1 meter. We were able to get that reduced clearance. So that many of the non-standard bridge we are able to make the same drawing for the standard drawings for the PSC.
Okay.
Okay, so thank you very much. So we will end this webinar today.
Thank you, sir.
Yes. Okay. Thank you. Thanks a lot.